Swayam Prabha. Digital India. Educated India.
Hello and welcome all to the lecture on basics of working drawing. I am Dr. Swayam Prabha, Assistant Professor at Department of Architecture and Regional Planning, IIT KHARAGPUR. To the lecture on basics of working drawing. So, when we look at construction drawings have been the mode of communication, and it is a well-known fact that it has been a universal language throughout all language barriers. It has helped man to communicate the ideas in the mode of drawings, which can be a simple collection of lines, right? Drafting over time has evolved as manual drafting, where you have traditional scales, ratios of certain scales which we use, and then furthermore these manual drawings have moved on to computer aided drawings, more commonly known as CAD drawings. And in recent times we have BIM models or BIM softwares, which are basically building information models, wherein you have information about the building in a form of drawing, which is also sometimes extruded in a three-dimensional form, right? Next, if we look at this, drawings are used in all fields. If you look at mechanical engineering, if you look at civil engineering, it is evident in structural management and structural design. Then furthermore, architecture relies largely on drawings, and furthermore an evolution or subset of architecture as well, if you see, is product design, where product designing has limitedly or invariably dependent on drawings, right? So furthermore, if you see industrial design as well, that also includes a lot of reliance on drawings, right? So we have been consistently and regularly relying on drawings, where we start with a plain blank sheet and then we evolve into a design, right? So using the sense of drawings, right? Furthermore, coming back to our subject, working drawings are a complete set of drawings, as we also discussed in the previous class, that working drawings are a complete set of drawings such that objects represent the building or the build form by itself, right, without any additional information. So in layman terms, if we say, a working drawing is basically the actual building or actual build form on plain paper. So we are doing the first execution of our building that we had thought or imagined to be there on our site on a two-dimensional plane, right? So traditionally, working drawings consist of two-dimensional orthographic projections, as it is available in that image on top. So you will see a two-dimensional projection here. So you see a two-dimensional projection around here, which has evolved into a site where you see the columns being placed. Then you see a three-dimensional extrusion of the same drawing, where you see columns and beams being developed out of that, and on top of that you get a roof structure and also the walls of the building, the windows, the chimneys and other parts of the building. So ultimately you are evolving from a two-dimensional space to a three-dimensional structure, right? So that's how we go about drawings. And when we look at evolution of a simple drawing from a planar two-dimensional orthographic projection to a three-dimensional space, then what do we see? We see that there will be plans such as this one, then there will be elevations such as this one, where you will see the elevation of a beam and two columns on this side. Then you will also have elevations of the completed structure, where probably you will see the wall, a window, a chimney here, and then a roof as well, right? So those are the things which you will see. Furthermore, to detail the building furthermore, you will have sections of this particular building as well, right? And then you do details of certain small corners, or say staircase or the window, so on and so forth. So there are different parts in which you have to give the details of the design. You need to look at how this particular part of the building needs to be enhanced further to give it that architectural flavor that you want to impart. Furthermore, these parts also require certain degree of specification. Say for example, we are looking at a window. So in the case of a window, what kind of material is to be used, what kind of wood or aluminum you want to use, what kind of glass you will be using in that case, what kind of sticking material which will be available, the kind of hinges on which the window will pivot or whether it will slide. So all of these things are to be included in the specification, and we will go to each of these parts eventually in the lecture series. Furthermore, when we look at drawings, these sets of drawings, before they go to the site, they need to be in certain formats, right? So we have 3 different formats usually practiced in an architectural firm, where the first format is a preliminary drawing. So in a preliminary drawing, you have the initial ideas about the project, what kind of building you will be designing, what will be the distribution of spaces along in that particular building. You will explore different concepts which you want to impart in that particular building. Say you are doing biomimicry and you are trying to mimic a particular part of tree or a leaf, say a leaf of a tree. So you are trying to look at that particular leaf, and then you have extracted some conceptual ideas from there. So these things gradually move from the biomimicry phase to the actual structural phase of how you will be implementing or how you will be abstracting this idea into a design format, right? So that is where you do concepts. Furthermore, you will look at the functional studies. Say for example, you have adopted the leaf form for your roof of the building, right? So you will double check whether it is functionally feasible to do that kind of a roof. Has it been done earlier? So all of that comes in the form of preliminary drawings, where you get inspired by the forms which have been tried or practiced elsewhere in the world at the first, wherein you do case studies, and beyond that you will start looking at the preliminary function which you can adopt that same typology of structure within your own building, within your own design, right? Going further, you will also see a preliminary estimate, a ballpark estimate of how much amount or how much will it cost to actually do that kind of design, right? So all of that is done in the preliminary drawing in the beginning, right in the beginning of the project. Say you are commissioned for a project, so you will start with the preliminary drawings. So there is where you ideate on ideas with your team, with the architects which you have on your team, and along with that you also discuss with the preliminary drawings a little bit with the client. So you get an initial idea. Once you have a initial go ahead from your client, then you move on to doing the working drawings, right? So in the working drawings, you are actually doing a complete set of all the technical information that will be required to execute the project which you have designed in your preliminary drawing, right? So when you move to working drawings, what you will see is you will have to create a complete set of drawings which will have all the technical information, all the different sizes, the quantities, the location of different elements which you are trying to adopt from your abstract phase to your final design phase, right? And you will basically be doing a construction on paper, right? So construction is to be executed as per the provided details in the drawing. So your specification of the material, as we discussed in the previous slide, will also come in here, right? And furthermore, once you start looking at the complete set of drawings, once you have completed these set of drawings, you start moving to the next phase, which is called presentation drawings, right? Say for example, you are doing a residential complex for a certain development firm, right? So a firm in a metro city wants you to do a complex of say 5 or 6 residential towers, each of 20 floors or something like that, right? And then you have to do a complete set of drawings, right? So your floor will remain more or less typically the same. If say all the buildings have only 2 BHK apartments, so all the floors will be more or less the same if it follows the same block, right? So you will do a working drawing of that block. You will replicate on how many number of floors that will have that kind of design will be there. And then furthermore, you will look at the different podium sizes and different things. Then moving further, you will start rendering the same drawing, the elevations in that drawing, the sections in that drawing, and you will create presentation drawings out of that, which will look something like this, right. So in a presentation drawing, you will be rendering, you will be actually trying to communicate how is the scale of the drawing evident, how the building will be scaling up, and how the surroundings of the building interact with the elevation or the design of that particular building. Usually these presentation drawings, if it is a completely commissioned project and you have received the project, these presentation drawings are the ones which end up in the brochure of such kind of development projects, right. So it's a part where you are actually doing visual communication to the potential buyer of that particular building or that particular place, right. So here a lot of times there is a complete artistic liberty given to the architect to develop and design the way the architect has imagined that particular building to appear for the common public, right, or to the buyer. Moving further, we need to realize and understand that this is an iterative phase, right. So we move from preliminary drawings to working drawings, then from working drawings to presentation drawings, and maybe it may so happen that when you have realized on the presentation drawing, the client may not be happy with the appearance of the design or the appearance of the building, how it looks when you have done the rendering. So in that case, what happens? So can you go back to the working drawing and fix few things? Maybe not, because it has all the technical details which are involved in there, right. So what is recommended, that you do a preliminary drawing again of that particular area, you fix that in the preliminary drawing, then you come back to the working drawing, right. Once you are back to the working drawing, maybe you have to fix a certain corner, say the front of this particular area. So you are fixing this, and that will change this particular part in the elevation, right. So this is how iterative it remains, right. So it is a complete interlinked process which you have to take care of as architects on the site, right, architects who will be executing buildings on site, right. So these kind of structures are very much evident when we are looking at construction drawings and we are looking at working drawings per se particularly, right. So what are the critical importance of having working drawings in any kind of construction phase, right. So first off, working drawings really help in becoming a important part of your contractual document. So whatever contract, say for example, we took up an example of a developer in the past slide, the last slide, we looked at that, yes, there will be a document with which is your working drawing, and on top of that, along with that document where you are signing an agreement with your client that yes, we will be working on this particular project, along with that, this becomes, the working drawing becomes a attached document which completes your portfolio of the design execution, which is a basic contract which you have to sign in the beginning of the project, right. So wherein here, near going to the completion of the project, these drawings can be referred back and you may check on different things and different aspects which will impact the development of the project, such as project cost, the material cost, how it has changed over time, how certain parts became more expensive than they were expected to be or estimated to be. So these are the things which you can basically do when you have the set of working drawings with your contract documents, right. So let's go from the top and see how and what all things make the working drawing really important in the case of construction execution, right. So the first thing will be, you can calculate the amount of labor and material cost and equipment estimation required. For example, labor, material and equipment cost. So in case of equipment cost, say you are doing a swimming pool, you are working on a swimming pool for a certain project, and you will require some specialized equipment like a earth mover, right, to excavate all the mud which is there to make some space for a swimming pool. So these are specialized equipments which may not be required for the other part of the project. So they need to be included in this budget, right. So that's where your working drawing will help you, that you look at the estimate of how much amount of soil you are going to excavate, land you are going to excavate from that particular piece of land, and then try to do the swimming pool using an earth mover, right? So that is one example I can give you on that particular part. Moving further, the structural consultant who will work with you closely on this particular project will be will get a big help of all the drawings which you have produced as working drawings, which will be further detailed for the structural details of the building. Now, the structural part, you will have footings, you will have columns, you will have beams on all of the building, and then following that you have your floors, your slabs, then you have your chhajjas and all the outgrowth parts wherein you will have cantilevers and things like that, right, including staircases. So all of those estimates, the structural design consultant or the structural design person with whom you will work as an architect for a certain project will be will receive a great help from the set of working drawings. Moving further, when we look at working drawing as a set of instructions, in the working drawing template, you will always have the location, the sizes, the details of various elements and materials which you will be using all across your building. All of those details are usually included in the drawing, right? So these things we will also talk about in the later part of this particular lecture, right? So we also have some examples about that. Moving further, you will be looking at these particular set also going for a building permit. So all the building permits which are issued by the municipal corporation or any authority wherein your building lies, in whose jurisdiction your building lies. So for that you will also require the building permit. So in that building permit approval or that building permit application for the approval, you will have to give a set of working drawings as well, right? So along with that, that's about the municipal corporation. But when we go to the site, or often it so happens that when you are doing your construction, you have done your base of the structure where your plinth is complete, you have done one floor of slab, second floor of slab, and now you have started doing your brickwork, and gradually it is also getting plastered. So in that particular case, sometimes the client also parallelly is working on the furniture which that person will be getting into this particular building. So your teams are probably working in different places. So a set of working drawings also help people or tradesmen to actually be on the mark and follow a certain design philosophy which an architect has given them, which an architect wants to communicate through that building. So all of those things will be included, and all of those things will be communicated through working drawings. So that's how important a tool, a set of working drawing is, right? Also, furthermore, and one of the important things that a working drawing does is it becomes a permanent record for future reference, for remodeling of your building, for expansion of your building, for checking some of the things which you can't see anymore. Say for example, the footing of the building, once you put the soil back on the excavated spot, you can't see the footing anymore, right? So a working drawing becomes a very good reference on identifying from which point, from one point on the boundary of your building, of your plot, how far is the footing, where would ideally the footing be. So identifying such locations, such spots for future expansion, so that you don't damage the structure while you are remodeling that particular area. Such things can be of like a working drawing can be of great use in such kind of execution projects wherein you want to do expansion of a building or remodeling of a building. Furthermore, if you are going to lease out or sell off this building to some other person, the owner and the client relationship can get a big support by a very legal documentary support of the contract along with a working drawing, right? So the basis of agreement on the owner and the client, because you can carry out the square footage area, you can carry out the quantities being used of certain material in the building construction, quantities of certain high quality or high cost material, say some imported marble is being used in the building. So to validate that yes, this much amount of marble or this much amount of certain material has been really used, you can execute that, or you can provide evidence of a working drawing of the quantities included in the working drawing as evidence, as a as a evidence record to the working drawing. Furthermore, certain components or smaller components such as the handrails, if you are doing custom handrails for your staircases, if you are doing custom balustrades for your staircases, if you are doing custom grills for your windows or custom gates at the entrance of the building, all of those things which are developed in an architect's office will have a working drawing which will be communicated to the different manufacturers from whom you can collect these structures or collect these elements of your building to complete your project. Lastly, to do your interior design, you will get all the square footage area and the surface area of different walls and punctures in the walls like windows and doors. So all the dimensions are available in the working drawing through the sections. Then your plumbing layout, say you have concealed plumbing, concealed electrical layout, all of that is also available in the working drawing in the electrical layout sheet, right? So you get all those details within the drawing itself. So the interior designer, the masons, the carpenters, the tradesmen, the people who will be owning this building later on, the people who will be coordinating between the development of this structure, the people who will approve this structure like the municipal corporation, all of them get a lot of help about understanding the project from a set of working drawing, right? So what all drawings actually go in the set of working drawings, right? So starting from the top, we always have a site plan. Moving further, we have a footing plan, then we will have a foundation layout, a foundation detail plan sheet, then furthermore we will have a column layout, we will have a beam layout, we will have a ground floor plan, a first floor plan, and then moving on, as many floors you would have with different types of custom forms or custom change in design. Those many floor plates or floor plans you will include in this particular set of drawings. Then you will go to the terrace plan ultimately, or the roof plan. If there is a sloping roof, you will have a sloping roof. If there is an accessible terrace with a water tank on top, you will have the terrace plan on there. Then for each of the floors, if the sizes of windows change for each of the floors, for every facade you will have a lintel layout, you will have the beam ceiling or the ceiling beam layout, you will have the beam details for each of the floors. Wherever the beams change, wherever the dimension of the rooms change, you will have different sizes of beams. So all of those beam details will come in one sheet. The slab details will come in one sheet on after the beam layouts. Sometimes the beam layout and the slab details are included in the same sheet as well. So you need to be aware of that, right? Sometimes even three things like the ceiling beam layout, the beam detail layout, and the slab details, all three are included in the same sheet, right? So these vary with individual architect's office, and things change as the size of the project also changes, right? So sometimes, say for example, you have a typical building, you have a building with a typical layout of the same kind of apartment structure, and you have 12 floors. So usually what happens is you give the ground floor layout, then first floor onwards till the 10th floor or the 12th floor, or how many floors you have, how many ever floors you have, till the terrace floor the layout remains the same. So you give you say that from floor this much, say floor 2 to floor 10, it is going to be the same thing, right? So that is mentioned on the drawing as well. We will talk about this in detail. I am just giving an example of that, right? Then furthermore, for doing the pouring of concrete, sometimes even the shuttering layout is provided. This often comes from the structural design team, who will be doing the execution, or who will be taking care of communicating with the actual contractor who will be doing the concrete work on the site. So the shuttering layout is by them, which is basically looking at how the scaffolding will be placed and how the formwork will be placed for pouring of the concrete to cast your beams, floors, beams, slabs and columns, right? Furthermore, you will have this comes from an architect's office, things from here onwards. So you will have the elevation drawings of all sides of the building. You will have sections from different points, always passing always on, in most cases, orthogonal to the walls which it cuts, right? Then you will have the staircase details. If the staircase size changes, you will have multiple different sheets, multiple different drawings for the staircase which changes. You will have the electrical layout, you will have the plumbing layout, you will have the tiling layout of different places. Say for example, you will have a bathroom and a WC area or a toilet area. So you are going to propose different types of tile sizes in these two locations. So that will have a different tiling layout compared to your living area, your kitchen area, and your balcony area, and so on and so forth, right? So you will have to have that kind of a sheet which explains all of these details. Furthermore, you will you may also provide furniture layout. This is not mandatory, but in case of custom furnitures where, say for example, you are trying to do a very vintage style of architecture or vintage style of design which you want to impart in that particular case of a bungalow, say. So you are doing a very heavy structure furniture, or you are trying to you are being inspired by older furniture. So you are going to do a furniture layout as well. In addition to that, you will also provide some furniture details. So some of the details might be inspired by some features which you will have to draft and communicate to the carpenter team. In several cases, these drawings are also done by interior designers. These drawings are also provided by architect's office who are doing the interior design for a certain project, right? So along with that, if an interior design project is also being executed by the same architect's office who has done the building, they will also provide interior elevations of the walls, the ceilings, the inverted ceiling plan of the lighting fixtures and other things, which will also be a part of the electrical layout. Furthermore, if there are specialized joineries, if there are specialized features in interior or exterior, say you are going to give a quince or a cornice of a certain junction of a ceiling and a wall, you will have to provide a joinery detail as well, that how it is to be executed on site. So all of those details are to be included. Furthermore, the last one is the toilet details, where in some of the pieces of the toilet, some of the fixtures of toilets and bathrooms which are available in the market, you may get the specification of them from the market and then try to include them in the toilet drawing itself, right? So these are some of the drawings which are essential to be there in a set of working drawings for a construction of a certain project, right? Moving further, you'll look at the initial sizes of how layouts are placed. So usually in several architect's office or several offices, we see that drawings which are communicated for on-site execution are often in A0 or A1 size, right? So the dimensions are available here. So an A0 size sheet is often of 841 mm to 1189 mm, which is a standard size. It's a universal size which you will find in different plotters, people who do the offset and plotting for you, DTP services. So often in A0 size plots, they are commonly used for site layouts of bigger sites and presentation of bigger sites on site, right? So you can have one single drawing on which all of the teams come together and they discuss on different corners and pieces of that particular layout, and you try to develop further on that. On A1 sheets, you often have site plans and floor plans. So A1 sheets are smaller than A0 sheets, so you also often do site plans on there. So in this case, it will probably be a bungalow or a twin bungalow or something like that, right? A typical floor plan would be there. Then A2 size details, you often go for details of sections, details of floor plans, the electrical layout and plumbing layouts, if you see, right? So as the scale, as the size of the object or the material reduces, we see that the scale of the drawing also reduces a lot. The size of the drawing reduces a lot. The scale might vary as required, because it will be evident much more clear in a smaller paper to discuss certain details, right. So, lastly, the A3 size drawings are often used in smaller details. In most cases, you will see that interior details, lighting design, the type of features, the type of material to be used, all of these are usually made available to the execution person within a A3 size drawing, right. So, these are the various sizes of drawing which are commonly used. This may also vary with different offices. Sometimes people also make a small book or a small reference report of all the design features, which are furniture details, interior details, material specification, all of that, and it goes in a A4 sheet, right. We haven't included that here, but that is sometimes done. So, just for information, I wanted to communicate that, right. Furthermore, let us look at the scale of the drawings. So, when we see a scale of a drawing, what do we mean? We are basically looking at the ratio between the size of the drawing of the building and the size of the building in real life. So, we are looking at a ratio of two things, both of the same object, but one in real life and one in a communication form, which is a set of a drawing. So, when we say that we are looking at a scale of 1:100, we basically mean that 1 unit of the drawing equals to 100 units in real life, right. So, when we say 1 mm in the drawing, we basically mean 100 mm in real life, 10 centimeter in real life, right. So, that is how we talk about the scale. In architectural drawings, if we see particularly in working drawings, when we see the usual scales which are followed is 1:50, 1:100, 1:200, and so on and so forth. It depends on the size or the scale of how large a particular site is. If a site is invariably very large, then we often also go to 1:500, or in a very large site we often go to 1:1000, but that is extremely rare. But 1:500 is something which some of the offices often tend to include the drawings for, right. So, here are some examples. So, here you see a typical floor plan being made in 1:100. The detail of area of within the drawing, where you are talking, when you are actually doing an elevation of a kitchen, where you see the cylinder unit, you see the bifolding shutter, the shelves in section, the drawers, the different drawers which are there, right, and then you see the dado of that particular area. So, these are interior drawings, so they are done in 1:5, right. Then furthermore, you see a kitchen cabinet being in detail, or sorry, this is a cove lighting. So, you see a cove lighting detail which will be part of the wall and the ceiling, a junction between the wall and the ceiling, and also a false ceiling at the bottom, right. So, you see that detail. So, this is again in 1:5, all right. So, these are certain things which we need to take care of, as we discussed in the previous slide as well, about the sizes of the different parts of the building. So, when we are looking at drafting, the choice of scale is completely at architect's discretion, right. So, the scale may differ with the generally recommended ones. So, it is not a hard and fast rule that these are the exact scales which someone has to use, an architect has to use for certain places. So, it is not at all hard and fast, but it is completely at the architect's office or the architect's discretion, right. So, all drawings, what is really important in this case when we are talking about scale is all drawings should be drawn to scale, right, and the denomination of the use scale should be shown in the title block. So, when we have a title block, when we have the complete set or the template of the drawing, right. So, within that template the scale is to be mentioned, right. So that we are not confusing someone who will be reading the drawing, right. So, they should understand that certain part of the drawing is at this scale or that scale or something else, right. So, what we see further is when we look at enlarged scales, we invert the units. So, here it basically means 50 units means 1 unit in real life. So 50 units in drawing means 1 unit in real life, and this can vary. So this can change from from 50 is to 1 to 20 is to 1 to 10 is to 1 to 5 is to 1 or 2 is to 1, so on and so forth. When we are doing some details in full size or full scale, say for example you are looking at a door knob which is custom designed, so a very small part of the building like a door knob or a hinge which is being made custom, that often is given in 1:1 scale, right? So that because it is done in custom manner, it will be manufactured especially for the building, so that will be provided in 1:1 from the architect's office. Then we have reduced scales, which we discussed previously, that we will have 1:50, 1:100, 1:200 or 1:500. So this is for the larger scales or larger sizes which we want to describe and present in a drawing format, right? So that's something to be remembered, right? So coming to the next part, which is quite important, is we also present the dimensions of the different parts of the building or the different facades of the buildings, or basically all the lines which we are drawing to describe a part of a building, those are provided, right? So right in this particular example, if you see, the dimensions are reading from the bottom to the right, right? So from the right side of the drawing you are supposed to read the dimensions of this particular block or particular roof which is being shown, right? The smaller dimensions are overall dimensions, and overall dimensions are also shown at the same time, right? So both dimensions are shown at the same time to ensure that the correct dimension is there. So for example, what I mean by that is the full length of this particular side of the wall is 15 feet, but if you see here, this one part and the other part is 9 and 6 respectively. So 9 plus 6 is 15. So when you do smaller dimensions and larger dimension at the same time in the drawing itself, where you see 15 here, right? So when you do these two dimensions in the drawing itself, what happens is you are also doubly checking whether the drawing is correctly done or not, or whether there is some issue with the dimensioning of the particular drawing. Also, one thing I must mention at this point is that units often are at the discretion of the architect, or what is being generally practiced in that part of the world, that whether it will be done in feet and inches, or it will be done in millimeters, right? Rarely or seldom it is done in meters, but usually it is feet and inches or in millimeters, right? So throughout the lecture we will see drawings or different set of drawings which will interchangeably have feet and inches and millimeters as well, and sometimes in certain cases both units are used in the same drawing, right? But that in that case the number of dimension lines, the number of dimensions you will input in a drawing will increase, like basically double up, right? So that becomes a bit of a challenge to read such kind of drawings in on site. So often architect's office always follows one dimensioning method and one dimensioning unit, right? So that is to be taken care of, right? So in each case, the drawing being in feet and inches, both feet and inches are shown separately by a hyphen. So that is to be remembered. So it can't be so that we just put the unit marks of feet and inches in case of feet and inches. So you have to make an effort to mention it with an hyphen. So that is to be remembered always, right? When you are doing a drawing in feet and inches, right? In all cases, you will rarely find that the dimensions are put internally, right? Internally we don't put dimensions. We always put the dimensions on the exterior, right? On the outside of the particular building footprint, right? Lastly, when we are looking at column center line, the center line to center line dimension should also be mentioned. What I mean by center line, I'll talk in the subsequent slides, right? So what are the different types of lines we use in describing a particular drawing is outlined here. So we start from the top, we look at the object line. So whatever object we are drawing, we will have a continuous line, right? So that continuous line will often show the edges of the building or the edges of a window or the edges of any element of a building or the design that you are doing, right. So all of those surfaces will be represented by a object line, right. Going further, we will have a dashed line, right. So what are the dashed line being used? These are used to represent all the hidden surfaces. Say for example, you are showing a ground floor plan, but on top of that on top of your veranda in a ground floor plan, you have a cantilevered roof, right. So the extent of that cantilevered roof will be shown in a dotted line. Say you have a window, you are showing the sectional plan of a window and you have a chhajja on top of that window, right. So that chhajja will be shown in a dotted line, right, or in a dashed line. So that is quite important. Then we have a dashed dot line, which is also called as the center line. So the center line represents the extent between the two center to center distances of say structural columns or structural elements of the building, the walls, the center line of a wall. So in between the dimension or the thickness of the wall, one line is drawn, which is the wall center line, so that you can calculate the center to center distances between your two walls which encompass or which contain your room space, right. So all of those things are shown in there. They basically show the symmetry on the axis. So where all there are asymmetrical features, it becomes easier to identify that beyond this particular center line there will be asymmetrical features or there will be symmetrical features, right. So this also becomes a point of reference in case of communicating a drawing, right. We will talk about this in detail in further subsequent slides, right. So they are often particularly in case of center line, they are extended slightly beyond the outline of your particular structure. So what happens is you want to give dimensions of certain walls, say a center to center distance of two walls. So you will have to draw the center line a little bit or extend the center line a little bit outside the limits of your outline of the wall, right. So we'll discuss this with an example in subsequent slides. Next is your dimension lines, which with the oblique tick mark, right. Oblique tick mark is most commonly followed. We don't use arrows because a leader line is also there. We'll talk about it next. So dimension lines, as we discussed previously about the dimensions lines, in dimension case you have to include oblique lines with dimensions, and in the middle you often write your dimensions, right. So dimensions with units. So here, since it doesn't have a tick mark, it is mentioned in mm, so which is 20 mm here, right. Then you have the leader. Leader basically points out all the details which you want to mention in the drawing with an arrow. So it's basically a directional arrowhead with a fine line, which often is thinner than the object line. So you are basically pointing out a certain comment which is to be made within the drawing. Say for example, you are communicating a feature to be added, a lighting feature to be added, a simple specification to be added at a certain point. So you will put a leader line there, right. Then we have a section line, which is which mentions the section number or section name in there. So here we see section P, which will be PP dash probably, and you will have a arrowhead on top of it pointing out the direction of on which you will be looking at in the section, right. So that's the section line for you. Then we have lastly the break line, right. So break line basically talks about the extent in which extent till which you are representing the drawing. It doesn't mean that the building ends there, but it basically communicates that beyond this point also there is the extent of that particular building. So here if we read out, it is a fine line which offsets to show a break or the termination of the partial view in the drawing, right. So that's what a break line does, right. So you have 1, 2, 3, 4, 5, 6, 7 types of lines to be taken care of when we are doing a working drawing, right. So here's an example, right. So here you see the center line which extends beyond the limit of the building, you see a dimension line around here, right? You see a center line marked by AB, right? So you have two demarcations of that, and when we are going top to bottom, we have 1, 2, 3, 4, 5, and so on and so forth, right? So from right to left we have ABC, and from top to bottom we have 1, 2, 3. Then we have the object line. So here you see the sill level of a window where is marked by the object line. So it's a clean straight line which is there. Then you have the section line. So here is a section called B dash with an arrowhead on top. So here we have the section line. Furthermore, we will have a break line which is right here. If you can see the zigzag notations on two parts, another one here, right? So that's the break line. So which basically communicates that yes, the building extends beyond this. This is just a partial view of the drawing. So this is how in drafting all the lines will be represented, right? So moving further, this is the component of a sheet. So when you have a template of a particular drawing to be communicated to the site, this is how we will place the drawing within this template. This is where you place the drawing. So this is your drawing area. Your building drawing will come in here, right, which is very important. And beyond that, you have the notes area, wherein you specifically mention some of the typical notes which are to be taken care of within the template, right? Then a border is to be mentioned. A border usually or typically follows distance which is equal on all sides, right? So you have a definite border on all sides. Then you have the legend space. So all of this block is your legend space. So all your details, which are all the symbols, all the different hatches which you will use within the particular drawing area, all of them are to be explained and described in the legend here, right? So furthermore, you will have your title block. Now in the title block, you will mention about the client details, about the drawing title of this particular drawing, the scale of this drawing, the date on which this was drawn, by whom it was drawn. And this particular block, if you see the title block of this drawing or any typical drawing, this marked with an hatch, is usually at the discretion of the architect's office. So the template a lot of times it changes. So sometimes it goes from here to here at the very bottom, these things come on top, and so on and so forth. So this has a bit of a flexibility, but usually the things which are placed on top remain more or less at the same spot, right? So notes remain at the same spot, the borders remain are retained like that. The legend for its readability is maintained here, because often we hold the drawing right at the bottom. So these are the 2 points where you will be holding the drawings, or here and here, for easy readability. So other parts you should be able to read when you have placed it on a table. So that's the whole idea of making things more readable. So coming to readability, or talking about readability, the descriptions of certain things, say for example you have a schedule of joinery or doors or windows, right? So all of these things will be placed in the top right corner, right? So that you are referring to the drawing here, and then you are immediately checking those notations or those symbols which you have provided within the drawing with the schedule provided on top, right? So that makes the drawing more communicable and more easy to understand for the person who is reading it on site or at their workshop, right? So what happens in the title block, right? So we talked about the title block, that it changes, or often it is shuffling with a few things here and there. So usually we follow I am just representing a simple template here, but as I mentioned earlier, all of this might also go at the bottom, but usually these things follow the same sequence, right? So here is where you see drawing number, you have your title descriptions of the drawing, the name of the firm, the scale of the drawing, the notes area which will go on top. Sometimes the notes area is also provided here, so that some of the corrections which are to be noted down on the site can also be mentioned here. So sometimes it is also provided just above the drawing title. So you can write some issues or notes which are being observed on site, right? So the date of issue of the drawing, which you see here, right? The scale of the drawing you see here, and the person who has drafted this, who has drawn this, is also mentioned here, right? So that the drawing goes back to the right person, because he knows how to edit this particular drawing. So that should be communicated to the same person. So that's why you also have the name of the person who has drawn. In some cases you also have another block which says approver, right? So a person who has approved or checked by, right? So these two things are also sometimes custom used. As I mentioned earlier, this is completely at the discretion of the architect's office, so they keep on changing a few things here and there, right? So this is again an example of how actual live drawing would have. So you see Gautam Society Cooperative Housing Society Limited. So that's the client name who has done the work with a architects firm, say named Entity Architects in Mumbai. So they have worked with this particular office. The structural consultant's name is also there. So you have this tech structural consultants there. So all of these things are there. This comes from a live project which has been very courteously and very kindly being given as a support for this particular lecture by Entity Architects in Navi Mumbai. So they have contributed their drawings for us to discuss in the lecture, right? Then coming to the drawing title, certain things are to be taken care of. That first thing is the conjunction and prepositions are not to be followed, right? So we don't say something for something. For example, lintel layout for first floor is something that we will probably never write in a drawing template, particularly in a drawing title. What we write is a very direct form of description of that drawing. We say first floor lintel layout instead of saying lintel layout for first floor. Okay, so these are certain things that we really need to know. Another thing that is to be remembered is there are often no abbreviations of any portion or any item names which are to be put in that particular title sheet. Okay, so the drawing title will rarely have your abbreviation. If it is a name of the client which is to be mentioned in the abbreviation, it is fine. So client name space is fine, like we saw in the previous example where we had the CHSS Cooperative Housing Society Limited. But in a drawing title, we will probably never use abbreviation for any portion or any item. Then drawing numbering, this is again at the architect's office discretion, but often these are most commonly followed disciplines of representing. So AR is used to represent architectural drawings, ST is used to present structural drawings, PL is used to present plumbing drawings, EL is used to represent electrical drawings, and IN is for interior drawings. So different notations which are mentioned in the first or in the beginning of the drawing number describes what kind of drawing it is. The next is used for the type of sheet. So whether it is a plan sheet, a sectional sheet, or an elevation sheet, that becomes a code. Sometimes offices also use some different numbers, say 93, 94, 95 or something like that, right? And then the sheet or the sequence number, which part or which sheet type has what number of sheets, that can be understood from the last number. So that is the drawing number sequencing which we follow. In case of a site plan, right, next we are going to the sites, we are going to the drawings individually. So in case of a site plan, we show that buildings where it is placed on the site. So here you see the building is placed right here, right? So you have a building right here, it's placed here, and you have this much of the site which is represented in a dotted line, right? So that's your site for execution, right? So that is a typical site plan. In a site plan, you locate the existing building and the proposed building. The topography of the site is mentioned, the contours of the site and things. The buildings that are to be demolished, say for example, this is an existing building and there is another building here which is to be demolished. So you will highlight that building and mention that yes, this is to be demolished and this is to be retained because it's an existing structure, right? So things like that. Moving further, the existing roads, the paved areas, the footpath, the landscape elements, all of those things are to be retained. The trees that are to be retained will be also drawn. The walls, fencings, the existing gates which are there or to be included need to be put in there. The orientation of the site, which is here where it is pointing towards the north, that is to be mentioned and it is to be drawn in that kind of orientation. Then you also need to show access road, which is also showed here, right? So all the access road with which you can get into the site are to be mentioned. And lastly, dimensions on all 4 sites are to be mentioned as we discussed in the dimension slide, right? So I think with that we can wrap up this particular discussion, this particular lecture. So I hope it was really interesting for you to learn about the different features or the different lines or the different systems that we use to represent a particular building in your format of the working drawing. So I hope it was useful for you. And moving on further, we will get into the different parts of the elevation, the plan and the section as we discussed today. So we will be getting into the details of different features, how we draw them, how we communicate them for effective execution of the thing. So, okay, so thank you very much for your time.